Identify which statement must be false for a distribution of scores. Either A, no one has a score exactly equal to the mean. B, no one has a score exactly equal to the median. C, no one has a score exactly equal to the mode. Or D, all of the other options are false statements. Alright, so let's have a look at these one by one and see whether or not they must be false. So A, no one has a score exactly equal to the mean. Well, I can think of situations where either could be true. So for example, I could look at a situation where nobody has a score equal to the mean. So I could have, let's say, my first score is 10, my second score is 20. Now, to find the mean, assuming that this is a population, it's going to be the sum of x over n. If you add these up, you'll get 30. And so this is 30 divided by 2 scores is 15. So it's certainly possible that nobody in this set of scores, in this distribution, has a score exactly equal to the mean. So that is not false. I could have a situation where 2 scores are 15, and even without doing any math here, you can see that the average is going to be 15. And so here's a situation where people do have scores exactly equal to the mean. So there's no statement that could be made one way or the other that has to be the case for any or all distributions. Maybe people in the distribution have scores equal to the mean, maybe they don't. Either one is fine. What about the median? When it comes to the median, I guess I could use, actually, let's create a new example. Let's say I have a simple set of values, 1, 2, 3, 4. Now, if I'm looking for the median, I first of all have to put my data into order, and you can see it's in order here already. And then I need to find the point at which half of the values are above and half of the values are below. So I have 2 scores that are below this line and 2 scores that are above in terms of their value, above the line. So my median in this case would be the average of these two. It's going to be 2.5. And you can see that no one score is exactly equals to 2.5. So here's a case where nobody has a score exactly equals to the median. But that doesn't have to be the case. I could have these scores. The median is right here at the 2. So the median is equals to 2. And there is a score that's exactly equals to the median. So I can't make a statement one way or the other that people cannot have or must have a score equals to the median. So it's not going to be A and it's not going to be B. What about C? No one has a score exactly equals to the mode. Well, I can certainly come up with an example where somebody has a score equals to the mode. My mode in this set of scores is equals to 3. And you can see that not only one, but many people, or many of the scores, are exactly equals to the mode. So it's possible to have a score exactly equals to the mode. Can this happen the other way? Not really. I can't have a distribution where there's no mode and then have somebody have a score equal to that mode that's not there. It doesn't really make sense. The mode has to be the most frequently occurring number in the distribution. So that means it's not just going to happen once, it's going to happen a lot. So you can't say that no one has a score exactly equal to the mode. In fact, the mode means that many, many people, the majority, or not the majority, but more people will have that score than any other individual score. So this is the one that I'm looking for. This one must be false. You cannot have a distribution where no one has a score exactly equals to the mode. The mode is the most commonly occurring score, so people have to have that score. So the answer here is C.